the inspector is likely correct in citing a 110.11 violation. The service equipment, including the meter, fuse box, and service disconnect, are located in a wooden cabinet lined with asbestos. This creates an enclosure that is classified as a damp or wet location according to the National Electrical Code or NEC Section 110.11 subsection A. In damp or wet locations, electrical equipment must be enclosed in a weatherproof enclosure or otherwise protected from moisture. The wooden cabinet, while it may provide some protection from the elements, is not considered a weatherproof enclosure. Therefore, the knob and tube wiring that is exposed within the cabinet before it enters the junction box is in violation of 110.11. The inspector is also correct in requiring the mast to be bonded. Per section 810.21, all metal masts are required to be bonded to the electrical grounding system. This includes masts that support antenna systems, as well as masts for service equipment. To address the violations, firstly replace the wooden cabinet with a weatherproof enclosure for the service equipment. Secondly, enclose the knob and tube wiring that is exposed within the old cabinet before it enters the junction box. This can be done with a rigid conduit or other approved method. And thirdly, bond the mast to the electrical grounding system using an approved bonding strap. It is important to note that there is an exception to section 110.11 subsection that allows certain electrical equipment to be installed in damp or wet locations without being enclosed in a weatherproof enclosure. This exception applies to equipment specifically approved for use in damp or wet locations. However, in this case, the knob and tube wiring is not specifically approved for use in damp or wet locations. Therefore, the exception does not apply. Let's delve deeper into section 110.11 and its implications for electrical installations in various environments. The core principle of 110.11 is safeguarding electrical equipment from environmental factors that could compromise its integrity and functionality. This section underscores the importance of selecting and installing electrical equipment suitable for its intended environment, ensuring both safety and operational reliability. Section 110.11 applies broadly to electrical equipment installed in diverse settings, ranging from dry indoor environments to harsh outdoor locations exposed to moisture, chemicals, or physical hazards. The specific requirements for each environment vary depending on the severity of the conditions. For example, equipment installed in a damp location, such as a partially protected outdoor area, must be suitable for damp conditions, while equipment installed in a wet location, such as an area subject to direct water spray, must be specifically designed for wet environment. The NEC defines damp and wet locations distinctly. A damp location is defined as a location subject to moderate degrees of moisture, such as some basements, some barns, and some cold storage warehouses, and partially protected locations under canopies, marquees, roofed open porches, and like locations. A wet location is defined as a location subject to saturation with water or other liquids such as vehicle washing areas, unprotected locations exposed to weather, and similar locations. In damp locations, electrical equipment must be protected from moisture to prevent corrosion and electrical faults. This can be achieved by using enclosures rated for damp locations, such as those with an EMA 3R rating, or by providing additional protection such as drip shields or rain hoods. In wet locations, electrical equipment must be designed to withstand direct exposure to water and other liquids. This typically requires the use of enclosures rated for wet locations, such as those with an EMA 4 or 4X rating, which provide a watertight seal to prevent water ingress. In addition to moisture, 110.11 also addresses the protection of electrical equipment from other environmental factors such as corrosive substances, dust, and physical damage. In locations where corrosive substances are present, such as chemical plants or industrial facilities, electrical equipment must be made of materials that are resistant to corrosion. This may involve using stainless steel, non-metallic enclosures, or applying protective coatings to metal surfaces. In dusty environments, such as grain elevators or textile mills, electrical equipment must be enclosed in dust-tight enclosures to prevent dust from accumulating inside and causing overheating or electrical faults. These enclosures typically have an EMA 12 rating or higher. In locations where electrical equipment is subject to physical damage, such as manufacturing plants or construction sites, it must be protected by physical barriers or enclosures to prevent damage from impact or abrasion. This may involve using rigid conduit, metal enclosures, or protective cords. Compliance with 110.11 is essential for ensuring the safety and reliability of electrical installations in all types of environments. Failure to properly protect electrical equipment from environmental factors can lead to a variety of problems, including electrical shock, fire, equipment failure, and downtime. To ensure compliance with 110.11, it is important to carefully assess the environmental conditions at the installation location and select electrical equipment that is suitable for those conditions. It is also important to follow the manufacturer's instructions for installation and maintenance to ensure that the equipment is properly protected. Now, let's shift our focus to the requirements for bonding metal masts, as outlined in Section 810.21 of the NEC. Bonding, in electrical terms, refers to the practice of connecting non-current carrying metal parts of an electrical system to the grounding electrode system. This creates a low impedance path for fault current to flow back to the source, allowing overcurrent protective devices, such as circuit breakers or fuses, to quickly clear the fault and prevent electrical shock hazards. Section 810.21 specifically addresses the bonding requirements for metal masts that support antennas or other equipment. The primary purpose of bonding these masts is to provide a safe path for lightning strikes or other electrical surges to ground, protecting both the equipment connected to the mast and the surrounding structure. The requirements of 810.21 apply to all metal masts regardless of their height or location. This includes masts installed on rooftops, on the ground, or attached to buildings. The bonding conductor used to connect the mast to the grounding electrode system must be sized in accordance with the NEC, typically based on the size of the service entrance conductors. The bonding conductor must be securely attached to the mast using approved bonding clamps or connectors. The connection must be made as close as practical to the point where the mast enters the building or the ground. The grounding electrode system to which the mast is bonded must comply with the requirements of NEC Article 250. This typically involves connecting the grounding electrode system to a ground rod, a metal water pipe, or a concrete encased electrode. In addition to bonding the mast to the grounding electrode system, it is also important to bond any metallic equipment connected to the mast, such as antennas, amplifiers, or coaxial cables. This helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electrical shock hazards. The bonding conductors used to bond the equipment to the mast must be sized and installed in accordance with the NEC. They must be securely attached to the equipment and the mast using approved bonding clamps or connectors. Compliance with 810.21 is essential for ensuring the safety of electrical installations involving metal masts. Failure to properly bond the mast can result in serious electrical shock hazards, equipment damage, and even fire. To ensure compliance with 810.21, it is important to carefully follow the requirements of the NEC and use approved bonding methods and materials. It is also important to inspect the bonding connections regularly to ensure that they are tight and free from corrosion. Now let's discuss some practical recommendations for addressing the specific violations mentioned. Firstly, the wooden cabinet housing the service equipment should be replaced with a weatherproof enclosure. This will provide adequate protection against moisture and other environmental factors, ensuring compliance with 110.11. The weatherproof enclosure should be sized appropriately to accommodate all of the service equipment, including the meter, fuse box, and service disconnect. It should also be made of a durable material that is resistant to corrosion and physical damage. The enclosure should be installed in accordance with the manufacturer's instructions and the requirements of the NEC. Secondly, the knob and tube wiring that is exposed within the old cabinet before it enters the junction box should be enclosed in a rigid conduit or other approved method. This will provide additional protection against physical damage and moisture, further enhancing the safety of the installation. The rigid conduit should be sized appropriately to accommodate the knob and tube wiring. It should be securely fastened to the cabinet and the junction box using approved fittings. The conduit should be installed in accordance with the manufacturer's instructions and the requirements of the NEC. Thirdly, the mast should be bonded to the electrical grounding system using an approved bonding strap. This will provide a safe path for lightning strikes or other electrical surges to ground, protecting the equipment connected to the mast and the surrounding structure. The bonding strap should be sized in accordance with the NEC, typically based on the size of the service entrance conductors. It should be securely attached to the mast and the grounding electrode system using approved bonding clamps or connectors. The bonding strap should be installed in accordance with the manufacturer's instructions and the requirements of the NEC. In addition to these specific recommendations, it is also important to conduct a thorough inspection of the entire electrical installation to identify any other potential code violations or safety hazards. This may involve checking the condition of the wiring, the grounding system, and the overcurrent protective devices. Any identified issues should be addressed promptly to ensure the safety and reliability of the electrical system. Let's consider the exception to 110.11 subsection A, which allows certain electrical equipment to be installed in damp or wet locations without being enclosed in a weatherproof enclosure. This exception applies to equipment specifically approved for use in damp or wet locations. In order for electrical equipment to be considered specifically approved for use in damp or wet locations, it must be listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories or ETL Intertech. The listing or labeling must indicate that the equipment has been tested and found to comply with the applicable standards for damp or wet locations. The equipment must also be installed in accordance with the manufacturer's instructions and the requirements of the NEC. It is important to note that the exception to 110.11 subsection A only applies to equipment that is specifically approved for use in damp or wet locations. It does not apply to equipment that is merely suitable for use in these locations. The term suitable is often used loosely to describe equipment that is not specifically designed for damp or wet locations, but may be able to withstand some exposure to moisture. However, equipment that is merely suitable for use in damp or wet locations does not meet the requirements of the exception to 110.11 subsection A and must be enclosed in a weatherproof enclosure. In the case of knob and tube wiring, it is not specifically approved for use in damp or wet locations. Therefore, it does not meet the requirements of the exception to 110.11 subsection A and must be enclosed in a weatherproof enclosure when installed in these locations. Knob and tube wiring is an older wiring method that is not designed to withstand exposure to moisture. The insulation on knob and tube wiring can deteriorate over time when exposed to moisture, which can lead to electrical shock hazards and fire. Therefore, it is important to protect knob and tube wiring from moisture by enclosing it in a weatherproof enclosure when installed in damp or wet locations. In summary, the exception to 110.11 subsection only applies to equipment that is specifically approved for use in damp or wet locations. Knob and tube wiring is not specifically approved for use in these locations and must be enclosed in a weatherproof enclosure when installed in damp or wet locations. Let's explore some additional considerations related to electrical installations in damp or wet locations. One important consideration is the selection of wiring methods. In addition to enclosing wiring in rigid conduit, there are other wiring methods that are suitable for use in damp or wet locations. These include liquid-tight flexible metal conduit, liquid-tight flexible non-metallic conduit, and Type UF cable. Liquid-tight flexible metal conduit and liquid-tight flexible non-metallic conduit are both flexible wiring methods that provide a watertight seal. They are often used in applications where flexibility is required, such as connecting to motors or other equipment that may vibrate or move. Type UF cable is a type of underground feeder cable that is designed to be buried directly in the ground. It is also suitable for use in wet locations, such as outdoors or in basements. When selecting a wiring method for use in a damp or wet location, it is important to consider the specific environmental conditions and the requirements of the NEC. Another important consideration is the selection of boxes and fittings. Boxes and fittings used in damp or wet locations must be listed or labeled for use in these locations. They must also be made of materials that are resistant to corrosion. Boxes and fittings that are listed for use in damp locations typically have an EMA 3R rating. Boxes and fittings that are listed for use in wet locations typically have an EMA 4 or 4X rating. In addition to selecting the correct wiring methods, boxes, and fittings, it is also important to properly install them. All connections must be made tightly and securely to prevent moisture from entering the electrical system. Any openings in boxes or fittings must be sealed with a waterproof sealant. When installing electrical equipment in damp or wet locations, it is also important to consider the effects of condensation. Condensation can form inside electrical enclosures when the temperature inside the enclosure is lower than the temperature outside the enclosure. This can lead to corrosion in electrical faults. To prevent condensation, it is important to provide adequate ventilation inside the enclosure. This can be achieved by installing vents or by using a desiccant. Finally, it is important to regularly inspect electrical installations in damp or wet locations to ensure that they are in good condition. Any signs of corrosion, damage, or moisture should be addressed promptly. Regular maintenance can help to prevent electrical shock hazards and fire. Let's discuss the importance of proper grounding and bonding in electrical systems, especially in relation to the scenario involving the knob and tube wiring and the mast. Grounding and bonding are two distinct but related concepts that are essential for electrical safety. Grounding refers to the connection of the electrical system to the earth. This provides a low impedance path for fault current to flow back to the source, allowing overcurrent protective devices to quickly clear the fault and prevent electrical shock hazards. Bonding refers to the connection of non-current carrying metal parts of an electrical system to the grounding electrode system. This creates a low impedance path for fault current to flow back to the source, ensuring that all metal parts are at the same electrical potential and reducing the risk of electrical shock hazards. In the case of the knob and tube wiring, proper grounding and bonding are essential for protecting against electrical shock hazards. Knob and tube wiring is an older wiring method that does not have a dedicated grounding conductor. This means that if a fault occurs in the wiring, there may not be a low impedance path for fault current to flow back to the source. This can result in a dangerous voltage in the metal parts of the electrical system, which could cause an electrical shock if someone comes into contact with them. To mitigate this risk, it is important to ensure that the electrical system is properly grounded and bonded. This can be achieved by connecting the metal parts of the electrical system to the grounding electrode system using approved bonding methods and materials. In the case of the mast, proper bonding is essential for protecting against lightning strikes and other electrical surges. Lightning strikes can generate very high voltages that can damage electrical equipment and cause fires. By bonding the mast to the grounding electrode system, a safe path is provided for lightning strikes to ground, protecting the equipment connected to the mast and the surrounding structure. It is important to use approved bonding methods and materials to ensure that the bonding connections are tight and free from corrosion. The bonding conductor must be sized in accordance with the NEC, typically based on the size of the service entrance conductors. In summary, proper grounding and bonding are essential for electrical safety. They provide a low impedance path for fault current to flow back to the source, protecting against electrical shock hazards and equipment damage. In the case of knob and tube wiring and mast, proper grounding and bonding are particularly important for mitigating the risks associated with these types of installations. Let's address some common misconceptions about 110.11 and its application. One common misconception is that 110.11 only applies to new electrical installations. This is not true. 110.11 applies to all electrical installations regardless of their age. This means that even if an electrical installation was installed before 110.11 was adopted, it must still comply with the requirements of 110.11 if it is altered or extended. Another common misconception is that 110.11 only applies to commercial or industrial electrical installations. This is also not true. 110.11 applies to all electrical installations, regardless of whether they are residential, commercial, or industrial. A further misconception is that 110.11 only applies to electrical equipment that is directly exposed to moisture or other environmental factors. While 110.11 does specifically address the protection of electrical equipment from moisture and other environmental factors, it also applies to electrical equipment that is indirectly exposed to these factors. For example, electrical equipment that is installed in an enclosure that is not weatherproof may still be subject to the requirements of 110.11 if the enclosure is located in a damp or wet location. Another misunderstanding revolves around the interpretation of damp versus wet locations. Some believe that if a location is only occasionally damp, it can be treated as a dry location. However, the NEC is clear that any location subject to moderate degrees of moisture is considered a damp location, regardless of how frequently it occurs. Another misunderstanding concerns the use of general-purpose enclosures in damp or wet locations. Some believe that if an enclosure is made of a corrosion-resistant material, it can be used in a damp or wet location without being specifically listed for that purpose. However, the NEC requires that enclosures used in damp or wet locations be specifically listed for that purpose. These are a few of the common misconceptions about 110.11 and its application. It is important to carefully read and understand the requirements of 110.11 to ensure that electrical installations are safe and compliant. Remember to consult the latest edition of the NEC and seek guidance from a qualified electrical inspector if you have any questions or concerns. Let's talk about the role of electrical inspections in ensuring compliance with 110.11 and other electrical codes. Electrical inspections are an important part of the electrical safety process. They help to ensure that electrical installations are safe, compliant with the NEC, and free from defects that could lead to electrical shock hazards or fires. Electrical inspections are typically conducted by qualified electrical inspectors who are employed by local municipalities or other government agencies. These inspectors have the knowledge and experience necessary to identify potential electrical hazards and code violations. Electrical inspections are typically required for new electrical installations as well as for alterations or extensions to existing electrical installations. The specific requirements for electrical inspections vary depending on the jurisdiction. However, most jurisdictions require that electrical inspections be conducted at various stages of the construction process, such as before the wiring is concealed, after the wiring is completed, and after the electrical equipment is installed. During an electrical inspection, the inspector will typically check the following items: the wiring methods, the grounding and bonding system, the overcurrent protective devices, the electrical equipment, and the overall condition of the electrical installation. If the inspector finds any code violations or safety hazards, they will issue a notice of violation. The notice of violation will typically specify the code violations that were found and the steps that must be taken to correct them. The electrical contractor or homeowner is responsible for correcting the code violations and requesting a re-inspection. Once the code violations have been corrected, the inspector will issue a certificate of compliance. The certificate of compliance is proof that the electrical installation is safe and compliant with the NEC. Electrical inspections are an important part of the electrical safety process. They help to ensure that electrical installations are safe, compliant with the NEC, and free from defects that could lead to electrical shock hazards or fires. If you are planning a new electrical installation or an alteration or extension to an existing electrical installation, be sure to contact your local municipality or government agency to find out about the electrical inspection requirements in your area. Always work with licensed and qualified electricians who are familiar with the NEC and local electrical codes. This will help to ensure that your electrical installation is safe and compliant. The role of electrical inspections cannot be overstated, particularly in older installations or when modifications are made. Regular inspections can identify potential problems before they become serious hazards, contributing to the overall safety of homes and businesses. In conclusion, understanding and adhering to electrical codes like 110.11 and 810.21 are paramount for ensuring electrical safety and compliance. Addressing violations promptly and utilizing proper grounding and bonding techniques are essential for protecting people and property from electrical hazards. Remember to consult with qualified professionals and stay informed about the latest updates to the easy to maintain safe and reliable electrical systems.